Okay, let's unpack this. Have you ever stopped to think about the incredible tech hiding inside things you probably use every single day? We often focus on, the screens, the cameras, but what about those like invisible superpowers working quietly away? Today, we're doing a deep dive into one of those unsung heroes, the barometric pressure sensor, specifically in consumer electronics. Yeah, our mission here is to explore how these tiny sensors went from being, well, basically simple weather tools to these absolutely essential parts. They're enabling applications now that honestly feel like they're straight out of science fiction. And here's the kicker, the really transformative part. They are now so incredibly precise. We're talking determining your altitude to within just a few centimeters. A few centimeters. And importantly, at a pretty low cost. Just imagine what that kind of accuracy actually unlocks for us.
It's really fascinating. The revolution in the core technology itself, we're mainly looking at two types here. Piezoresistive and capacitive sensors. So think of piezoresistive as measuring changes in electrical resistance when pressure hits them. And capacitive ones, they detect shifts in like an electrical charge. For a long time, piezoresistive was sort of the go-to, the gold standard. But the recent leaps, especially with capacitive sensors like, say, the BMP 580, they've just completely changed the game.
Okay, so when you say change the game, what does that actually mean? Like performance-wise?
Oh, it's a massive difference. Game changer is the right word.
Yeah.
Take that BMP 580 I mentioned. It boasts improvements like 85% less current consumption.
85%?
Yeah, 85. And 80% less noise compared to the previous generations. This isn't just, a small improvement. It dramatically extends battery life. And that makes these sensors just perfect for all kinds of battery-powered portable things. Your phone, your watch. It fundamentally changes what designers can even think about putting in these devices.
85% less current. Wow. That sounds amazing for anyone like me who's constantly watching their phone battery drain.
Yeah.
But okay, how does this tech actually translate into, real-world impact for you listening?
Well, it means these sensors are already affecting your daily life, sometimes in really critical ways. Take emergency calls, for example, E911. These sensors are crucial for helping first responders find you faster, especially inside buildings. They provide floor-level accuracy.
Floor level, not just the building address.
Exactly.
Yeah.
The E911 mandate in the U.S., for instance, it requires 3-meter vertical accuracy for 80% of calls now. That's potentially life-saving stuff, knowing not just the building, but which floor you're actually on.
Wow. Okay, that's huge. And beyond emergencies, what about the more everyday ways they pop up, like fitness tracking? I've heard they're doing some pretty advanced things there, too.
Absolutely. Yeah, fitness is a big one. These tiny sensors can detect incredibly subtle changes in air pressure, so your device can know if you're walking up or down just a single stair step, or even count things like pull-ups. To do that, they need a remarkable vertical resolution. We're talking less than 4 centimeters.
Hold on. Less than 4 centimeters. For measuring air pressure, that seems almost impossibly precise.
It is. It really is. The sensitivity needed for that kind of fitness tracking is just astounding. Think about a typical stair step, maybe 17.5 centimeters high.
Okay.
That difference corresponds to only about a 2 Pascal pressure change. 2 pascals. To give you some perspective, that's kind of like sensing the weight, the mass of a single mosquito landing nearby.
A mosquito? Seriously?
Seriously.
Wow.
So no, your heavy breathing isn't going to trick it into thinking you climbed a flight of stairs, but it really highlights the incredible engineering that's going on inside these tiny components. And if you connect this to the bigger picture, these sensors are also driving advances elsewhere, like non-invasive blood pressure measurement.
How does that work?
The idea is getting continuous, accurate readings right from inside your ear canal, no cup needed. Still early days for some of this, but the potential is there. And then on a totally different scale, they're helping Wi-Fi. Specifically, the new Wi-Fi 6 gigahertz standard power access points, they need to report their precise height above terrain, or HAT.
Height above terrain. Why does Wi-Fi count?
It's all about regulations, compliance. It's a critical FCC requirement, actually. Knowing the precise height helps prevent interference. Interference with other really important services using those same frequency bands, like satellite links, so these sensors are constantly measuring, helping everything coexist smoothly, making our connected world work without messing up other vital systems.
It's genuinely remarkable to how it does all these daily companions are comfortably pushing boundaries protected so small and invisible, from literally helping save lives in emergencies to fine-tuning the spots. These barometric pressure sensors really are.
Now, the name of this is BHI 380. Stick around a little bit longer. and then you will be able to get one of those wonderful goodie bags in a
The possibilities seem, well, pretty endless.
Thanks for watching. I hope you liked it or learned new things. Please also visit me on X, Instagram, or read my blog articles on WordPress. Bye.